So we're looking at example 6, Betty and Sue Lynn comparing the number of likes they each received on their pages on a social media site. And they tracked the number of likes they received for 5 days. They each recorded their likes in different ways, one in a graph for Betty and Sue Lynn recorded in a table. And so we're looking at comparing who received more likes per day. We want to find the graph to find the unit rate for Betty. And remembering that that unit rate is just another way to say slope. So we want to compare 2 points to find the slope. So I'm going to kind of look at that table and decide on 2 points. The first one I'm going to choose is 160. And so that would be my first ordered pair. And then I'm going to look at 3 and 180. So choosing some points that are nice and neat on whole number corners there. And so that second point again, 3 and 180. Then to find our unit rate, that's our slope. We're doing change in y over change in x, which you should be familiar with at this point in time. So we're doing 180 minus 60 over 3 minus 1. So working that out, we should get 120 over 2, and 120 over 2 gives us a slope of 60, or a unit rate of 60 likes per day for Betty. And then we're going to find the table, use the table to find the unit rate for Sue Lynn. So again, we just choose 2 points. So I'm going to choose the first 2. So I'm going to say 1 over 1 comma 55 and 2 comma 110. And then again, finding slope. So we have 110 minus the 55 over 2 minus 1. And we do our subtraction to find our slope. And that subtraction gives us 55 over 1. So for Sue Lynn, that is 55 likes per day. And comparing those, then, we would say that Betty's 60 likes per day is greater than Sue Lynn's 55 likes per day. Right, then we're going to move to our next example, which may on your sheet be labeled example 6 again, so just make sure you're really looking at the second example 6, which should be example 7, the equation y equals 40x. So moving on to that. All right, so looking at example 7 with an equation y equals 40x represents the height in feet, and that information I'm just getting from the table of a hot air balloon after x time in minutes. And we're supposed to draw a graph that represents that equation. So we have our equation y equals 40x, and so we're just plugging in those values where we have our x values and our y values. So this is the equation we're using, y equals 40x. And so for our first point, we have y equals 40 times 0 for 0 minutes, and of course at 0 minutes the height of the balloon would be 0 feet. And then for the second situation, our x is 1 minute, so it would be 40 times 1, which our balloon's height would then be at 40 feet. and y is equal 40 times 2 for 2 minutes, and so the balloon at 2 minutes would be at 80 feet. And for the next one, y is equal to 40 times 5, and 40 times 5 would give us 200 feet height in 5 minutes time. So that's just plugging into the equation. Now, then we want to take that down to the graph and plot those points. So we want to label our axes. We have the height and our title. So we have the height of a hot air balloon as our title. And another L there. Okay. And then our X is our time in minutes. Well, let me just change my, make sure we can see our bottom there. So time in minutes. And our Y is our balloon height in feet. Okay, and then we would label our graph. We want to label our graph and our time in minutes, starting at 0, 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes, and on. And then our height, we're looking at 20, 40, 60, 80, and so on, labeling our y-axis. All right, and then plotting our points. So we have the point 0, 0, so that's our initial value, and then we have 140 and 280, and after 5 minutes we're at 200. And so I'm going to do the best I can here to create a straight line connecting our points. So the graph above there represents the equation y equals 40x and the height of the hot air balloon over time.